everyone. So welcome to our last assignment of the semester. Keep in mind that we're not doing anything new. All we're doing is practicing the quadratic formula. So the way this is going to happen is I'm going to assign this as a note. I'm going to do all the examples to the left, so the odd numbers like 1, 3, and 5. And then you will be responsible for doing 2 and 4 on your own. If you look at the bottom of this page or the second page, there's an answer key to check your answers. Keep in mind that when I do example 1, number 2 is almost exactly like number 1. When I do number 3, 4 is almost exactly as number 3. What I mean by the same thing is that your solutions are going to be very, very similar. You'll notice that I arrived to 2 solutions, 1 solution, imaginary solutions, but nonetheless, they mirror each other in terms of solutions. So let's go ahead and just remind ourselves of what is the quadratic formula. So remember, the quadratic formula is just a very special formula. Pretty much it's a shortcut to completing the square. Now, in order to use a quadratic formula, you always have to have something in the form ax squared plus bx plus c is equal to 0. Once you have a quadratic equal to 0, you can use the formula. The formula is x is equal to a negative b plus or minus the square root of b squared minus 4 times ac, all divided by 2a. Of course, this looks like a super complicated equation with, let me see, 1, 2, 3, 4, 5 things to plug in, but the more you practice, the better you'll get at them. And again, my strategy here is to teach you strategies that work for me in order to not help me make mistakes. So, first things first, know what you are doing with solving these problems. You are looking for an x that when you square it, times it by 3, and then you add 8 times that same x, it is equal to 16. That is what we're doing. We're looking for an x to make this equation true. The way we're going to do it is by the quadratic formula. The way I like to set up my quadratic formula is I pretty much write the equation, but everywhere there's a variable, I leave open parentheses. So that is exactly what I'm doing here. I am just leaving open parentheses everywhere I have a variable, so that way I can go back and plug in what I need to plug in. Now, one thing I would highly suggest is to always keep that negative outside of that b, or in this case, when I'm plugging in my values outside of those parentheses. So, all right, one thing I did forget, and I'll do it in a different color so that way you can see it, is that when I was going to identify my AB and my C, I noticed that this quadratic is not set equal to 0. But it's really easy to do that because all I have to do is move everything to one side. So I'm moving the 16 over, I end up with 3x squared plus 8x minus 16 is equal to 0. Now that it's equal to 0, I can easily identify my A, my B, and my C. Remember that your A is always in front of the x squared, so in this situation it would be 3. Your B is always in front of the x term, and then your C is always negative 16. So now that you have your A, B, and your C, you got your signs correct, or I do. I can go ahead and plug away. So this is supposed to be a negative B. Your B again is a positive 8. Plus or minus b squared, which is an 8, minus 4 times a, which is a 3, and your c, which is a negative 16. All divided by 2 times a, which is a 3. Now again, you are never probably going to get this right if you plug it all into the calculator. There's just too much things. There's no plus or minus. This is what I do in order to not make mistakes. I always look at the part of the quadratic formula that I can solve myself. A negative times a positive is a positive 8. So I end up with a negative 8 plus or minus the square root of all that garbage. I'm going to go ahead and plug in all that stuff in my calculator in a second, but as of now, I'm going to do what I can do in my head because those are always going to tend to be easy. So 2 times 3 is 6, so there's my 6 at the bottom. And now I have to figure out what all this chunk means. And that's what I'm doing right now. I have my calculator. Remind yourself to always plug it exactly the way it is. Plug it in terms of parentheses, everything that you see on there, make sure you're plugging it, again, exactly the way you see underneath that square root. Click enter on your calculator, you'll notice that you end up with 256. So when I see mistakes, usually it isn't in the plugging in. Usually is in what to do first when you have this monstrosity of a formula. I usually tell students to go from here, and then they tend to not make as much mistakes. So let me go ahead and finish this. Now that you've figured out what everything equals underneath the square root, you can see if it is a perfect square. Now, does there exist a number that times itself to equal 256? And the answer is yes, because the square root of 256 is 16. 16 times 16 is 256. So just to simplify that, actually taking the square root of it end up with negative 8 plus or minus a positive 16, because remember I took the square root of it, divided by 6. Now remember that this is a plus or minus. There is a hidden two equations, technically. I'll change colors so you can see a little better. There's a positive and a negative, so let me split this into two different. This is negative 8 plus 16 divided by 6, and negative 8 minus 16 divided by 6. Again, all I did there was separate my equations. Now you just got to do math. Negative 8 plus 16 is a positive 8 divided by 6. If you reduce this, you end up with 4 over 3. If you go right over here, you end up with negative 8 minus 16, which is a negative 24, divided by 6 is a negative 4. So if I did everything correctly, I know it's really easy to make a mistake. But again, just double check, make sure you take your time, and go from there. So that is the first problem. Make sure you have it in your notes. The second one is all you guys. Now, the one thing I have to remind yourself is that when you set this equal to 0, remember that you always want to not confuse your A, B's, and your C's. Your A is going to be in front of the M squared, your B is going to be in front of the M, and your C is going to be. So notice that I just didn't put it to the end. I put it in the middle, just kind of like the quadratic formula suggests, just to make sure I don't mess up my A, B, and my C. Now, let me go ahead and go from there. Okay, double check and make sure I've got my answers correct there. What are we searching for, number 3? Let's see what's going on. Let's do number 3 there really quick. Excuse me. So I notice again that number 3 is not set equal to 0, so this is an easy fix. I'm going to add 2 to both sides. Keep in mind, since I'm adding 2, I put it underneath my constant because I could actually simplify a lot easier. I end up with 4b squared minus 6b minus 6 is equal to 0, or negative 6. And now I can see I know what my A, my B, and my C is. My A is going to be a positive 4, my B is going to be a negative 6, and my C is also going to be a negative 6 in this situation. Now I have to go ahead and plug in my formula, so x is going to equal, in this situation, it would be a b. I want to mark you wrong if you put an x, as long as you know you're solving your variable. But you'll notice in this situation, they're actually b's, so we're looking for b's. A negative, whatever b is, plus or minus the square root of whatever b is squared minus 4 times a times c, all divided by 2a. Make sure that everything is covered by the square root, because you're taking the square root and everything's in the inside. Remember, while you're learning this, I would always write it so that way you can reference it as well. So a negative b, my b is a negative 6 in this situation, which is also going to get squared in the square root, minus 4 times a, which is a 4 times a, which is a 4, and then my c is a negative 6, all divided by 2 times a, which is a positive 4. Now remember, what I like to do is distribute my negative. In this situation, I would end up with a positive 6 times the square root of all this garbage that I'm going to figure out in a second. 2 times 4 is 8. Now I'm going to go to my calculator and figure out what all that is. Again, remember to always use your parentheses, especially if you have that negative 6, to make sure you don't make mistakes. Here I go, type it in away. And I end up with, double checking because you know how easy it is to make a calculator mistake, 132. Oh man, now you can notice that this one's probably going to be one of the tougher ones, because 132 is not a perfect square, but you do have to simplify. Now remember, when dealing with big numbers, my suggestion is just to take those perfect squares and start dividing them away. Start dividing them by 4, start dividing by 9, any perfect square in order to simplify. You'll notice that whenever you have 132, you'll notice that when you try to divide 4, you'll figure out that 32 is actually just 4 times 33, and you know how to simplify this. The square root of 4 is just a positive 2. Your 33 has to stay in the square root. So you notice that this one was actually not very tough because it was the first perfect square available. So all I did there was take a little side note and simplify square root of 32. Let me go ahead and finish this. 6 plus or minus 2 times the square root of 33 all over 8. Remember, you have 2 equations that you have to show me. I'm going to change colors so that way you can even see me. Not one of these already. I end up with 6 plus 2 square root of 33 all over 8. Let me repeat that because I think I said it wrong. 6 plus 2 times the square root of 33 divided by 8. And 6 minus 2 square root of 33 all divided by 8. Now keep in mind that we have something plus something times something all divided by something. Now this is an incognito fraction. Is there any number that we could do to reduce all these numbers? And the answer is yes, because 2 divides all these. So this can actually simplify to 6 divided by 2 is 3. 2 divided by 2 is 1, so I'm not going to write it since I have that 33. 8 divided by 2 is 4. I can no longer reduce. I cannot divide 33 because it's the square root. I'm ready to move on from there. All right, so this one over here, more of the same. You can divide the top and the bottom by 2. You end up with 3 minus square root of 33 divided by 4. You're all done, and that's pretty much it. So you'll notice in this one that it took a little more work because you were simplifying the square root. The quadratic formula is the same thing. The only difference is that the simplifying the square root is where things can get a little more, I wouldn't even say more challenging, it's just more pre-work. So you'll notice in this last one that we're going to end up with imaginary numbers. The good thing it's already set to 0, so we could go ahead and figure out what our A, B, and our C is. Notice that my A is 3, B is -2, and C is a positive 2. Now you might see that glitch. Just ignore it. Hopefully it goes away quick. All right, cool. Now let's go ahead and use my formula. So in order to do it, it's going to be a negative, whatever B is, plus or minus the square root of B squared minus 4 times A times C all over 2 times A. Your B in the situation is a -2. Your A is a 3, and your C is a 2. 2 times A, which is a positive 3. So I plugged in everything. I'm making sure, because again, this is a lot of plugging, so make sure that you take your time. And now let's go ahead and figure it out. Do the stuff that you can do in your head. Notice that I always set myself up for this. A negative times a negative is a positive 2. 2 times 3 is a positive 6. Plugging all this in the calculator to figure out what all that equals. Don't forget your parentheses, especially right here at the beginning of that -2 squared, because you'll notice you get a different answer. So here I go, I'm plugging it away, and I end up with -20. Oh man, so you can see here that, our past units come to, I wouldn't say haunt us, but to remind us. We have negatives, we have a 20. We can simplify this though, because when I take the square root of a negative, all that is an I. What is a perfect square that multiplies to 20? Well, it's just 4 times 5. So if you were to take out that 4 afterwards, it would become a 2. Don't forget you have an I out there, and your square root of 5 will stay inside. So this actually all just simplifies to 2I square root of 5, all divided by 6. Notice that I'm going to simplify before I make my two equations. I have 2's here I have something that could all be divided by 2. My leading coefficients, so I would end up with 1 plus or minus a single I square root of 5 all over 3. And let's just write our two equations to get used to seeing 2. So we see 1 plus I square root of 5 all over 3. Then we have 1 plus I square root of 5 all over 3. Now keep in mind that I wrote plus twice there. Do not be like me. Do as I say, not as I do. Don't forget that it was a negative because there's the positive and a negative. And that's pretty much it. That's all you need for quadratic formula. Then the following 3 are just your homework for today. And that's it. All right.